In today's lecture, we shall discuss about how to write a program for 8086 processor to convert a packed BCD number into unpacked BCD number. Now here, before writing the program, I would just explain you what is a packed BCD number and unpacked BCD number. Suppose we have this number 4 and 5, right? So these are the BCD numbers. Now this number 4, 5 in binary form, it will be represented as 4 means 0, 0, 1, 0, 0, 0, 1, 0, 0, right? So this denotes 4 and 5 is 0, 1, 0, 1. This is 5, right? And this 4, 5, it is represented in 8 bits, and this 8 bit will be stored at one memory location, right? So two BCD numbers 4 and 5 can be stored at one memory location where we store 8-bit number. Now unpacked BCD number means this 4 and 5, right? So 4 will be represented by 0, 4 H, and this 5 will be represented by 0, 5 H, right? So here this 45, this is packed. This is packed BCD number. And unpacked BCD number equivalent to 4, 5 will be 0, 4 and 0, 5, right? So these are unpacked BCD numbers. So 0, 4 will be represented as in terms of binary 0, 0, 0, 0, this is 0, and 4 means 0, 1, 0, 0. Same way this 5, 0, 5 is 0, 0, 0, 0, and 5, 0, 1, 0, 1. So this 45 in unpacked form is represented by two combinations of 8 bits. This combination of 8 bit represent 4, and this combination of 8 bit represent 5. And two memory locations are required to store these unpacked BCD number. At one location we will store the binary form of 0, 4, and at second location we will store the binary form of 0, 5, right? So packed BCD numbers is having a higher packing density, right? Whereas unpacked BCD number is having low packing density. So we will write a program to convert this packed BCD number, like for example 45 into 0, 4 and 0, 5. Okay, so this is the program. Here the first instruction, see, first two instructions is used to initialize my data segment register. So my aim is to store 2000H in DS register, data segment register. For that, there are two instructions, move AX comma 2000H and then move DS comma AX. Now this is my data segment memory area, right? This is my DS. And in this data segment memory area, there are different memory locations. And these different memory locations are having the offset addresses like starting from 0000H, 0001H, 0002H, 0003H, 0004H. Like this, the last offset address of this data segment memory area will be FFFFH. So here at offset address 0000H, we are having a number, let us assume this 45H. This is a packed BCD number, right? Now our aim is to convert this in unpacked form and store it, the unpacked BCD numbers from the location 0001. So these two locations, this and this second one, are used to store the numbers like 04 and 05, which will be unpacked form. So here now you see this instruction, I have initialized my SI register, right? So with this instruction, my SI, source index register, will become 0000H. So this 0000H offset represents the memory location where I have stored my packed BCD number, that is 45H. Now next instruction, move DI comma 0001H. So this is the next, this offset address from where I would like to store my unpacked BCD numbers, right? So my DI, I will note down, my DI will become, after execution of this instruction, 0001H. Now you come to next instruction, move AL comma SI. So now with this instruction, what we can do, we can store the value stored at offset SI into AL register. So at SI, content of SI denotes the offset address. So in SI we have 0000H. So at this offset we are having a data 45H. That will be stored in AL register. So in AL register we have 45H. Now next instruction, we will perform the AND operation with the content of AL and 0F. So in AL we have 45H. So 45 means 0, 1, 0, 0, this is 4, and 5 is 0, 1, 0, 1, this is 4, 5. So this will be ANDed with 0F. 0F means 0, 0, 0, 0, and F is 1, 1, 1, 1. So with this, what will happen? We will get 1, 0, 1, 0, and 0, 0, 0, 0. So this is the result which we will get in AL register after performing the operation this AND AL comma 0F. So what is this value? This is 0, 5. So this is 0, 5 H, which is the unpacked form of this file. Okay, so now we got the unpacked form of this file in AL. Now you see the next instruction what we have written, move within bracket di comma AL. So this instruction will load the content of AL at the memory whose offset address is defined by di. In di we have 0001H. So here at this offset we are having 0, 5 H. Okay. Now already we have converted the 5 BCD number into 05, which is unpacked form of 5. Now we have to convert the 4, this 4 into unpacked form. So now the next instruction INC this we have written so that the di value will become 0, 0, 0, 2H, right? So the next memory location we have now bring in di register so that when we will convert the 4 in unpacked form, so we can store at that location. Now next instruction, move AL comma within bracket SI. So in AL we will again load our data 45, right? So in AL again 45 will be there. Now and AL comma 0F0. So in AL we have 0, 1, 0, 0 and 0, 1, 0, 1. This 45H we are having in AL. Now what we will do, we will perform the AND operation with F0. Okay, with F0. F0 means 1, 1, 1, 1 and not means 0, 0, 0, 0. So our answer after the AND operation will be 0, 0, 0, 0, 0, 0, 4, 1, 1, 0, this. So this is 4, 0. So now in AL we have 4, 0, H, right? So now what we will do, we will perform basically this ROL operation, instruction, ROL, content of AL, right? This content of AL, we will rotate left side 4 times. So when we will rotate this 4 times, so you see what will happen. Our content of AL is 0, 1, 0, 0, 0, 0, 0, 0. So these 4 digits, they will be rotated and they will be brought to this side, 0, 1, 0, 0, right? After ROL instruction. So what we will get? 0 and 4, which is the unpacked form of 4. Unpacked BCD form of 4, right? So this is our aim. So for this, what we will do, we will write this instruction, move CL comma within bracket CL comma 04. In CL we will load the value 04, means for how many times we want to rotate the content of AL, that first we will load in CL. Then the next instruction, ROL, AL comma CL. This instruction will rotate the content of AL 4 times left side. And finally in AL we are having 04, and with this last instruction, move within bracket di comma AL, that value will be loaded at offset 0, 0, 0, 2h. So here 04h will be loaded. So this is the program, and here this is the program I have written by using the directives, right? Same for conversion of packed BCD number into unpacked BCD number. Okay. So now I will show you the demonstration of this program. I will start the DOS box. Then mount C space C colon backslash 8086. Enter. C colon. Okay. Now edit lab1.asm. So here this is the program. Okay. So here it is AL. In AL we have loaded this value. After this we will perform AND operation, and AL comma 0FH. After this, the content of AL will be loaded in the memory location. Move within bracket DI comma AL. Then INC DI. Then move AL comma within bracket SI. Again the number will be transferred to AL register. Then AND AL comma 0F0H. Then move CL comma 04H. Then ROL space AL comma CL, and then move DI comma AL. That's all. So this is the program. So I will save it and exit. Okay. Now I will generate the object file by using MASM tool. Okay. Now I will use object file with the link tool, and I will generate the exe file. Exe file is generated. 1 minute. There is one error is there because object file is not properly generated. Illegal use of registers. I think at line 16. I will see this. What is the error? Line 16. And AL comma 0F0H, and operation is to be performed. There is no problem in this end. Move CL ROL AL. There is no error here, so Again I will check this. AL SI AL 0F move DI comma AL INC DI move AL comma within bracket SI and it seems to be correct. Let us see once again. MASM. Illegal use of register. Illegal use of register. Let us see once again. Move AX comma data, move DS comma AX, move SI comma offset N1, move SI, move DI comma offset result, move AL comma within bracket SI and AL comma 0F, move DI comma AL, okay, INC DI, move AL comma within bracket SI, okay, and AL, oh, here I kept dot, it is not dot, it is comma, right, now it will work. Yes, now it is working. Now link, now debug. Okay, I will unassemble the program and I will show you my data 45. It is at data segment 076A colon 0000. So here you can see that where data 45 is there, and after that next location is 00, and here first unpacked BCD number will be stored, and the next location is again 0, where the second unpacked BCD number will be stored. Okay, so I will execute the program now. Okay, now I will show you the result once again. D space DS colon 0000, and you can see our data is 45. After that you find at next location 05 is stored, which is the unpacked BCD form of 5, and at the next location we have 04, which is unpacked BCD form of BCD number 4. So in this way we can execute this program. Okay.